Okay, so we're gonna warm up. We're gonna take a look at number 10. We're gonna do a couple examples there. Okay, so number 10, page 3. And we're calculating the pH of 0.002 molar HCl. Okay. Now this problem tells us we're looking at strong acids and bases, but the first thing we want to say is, all right, do we recognize this as being one of our strong acids?
Yes.
Yes. Okay. So strong acid means if I have 0.002 molar, right, that means that my concentration of H3O plus is also what?
0.002.
0.002 molar. Good. Okay, and if I know the concentration of my H3O plus, what equation can I use to get my pH?
Do you subtract negative log?
Yes, we're going to do pH equals negative log of H3O plus. Okay, so I'm going to take the negative log of 0.002.
Wait, were you here for this one?
No.
Oh yeah. So it equals.
So I get a pH of 2.7.
And pH doesn't have like a unit, right?
No units for pH. Okay, let's look at part B. Okay, I have 3.45 times 10 to the negative 4th molar HNO3. Do I recognize that as one of my big six? Yes. Okay, so if this is my concentration of strong acid, my concentration of H3O plus is the same thing, right? So to get my pH, negative log. Good. .5? Yes.
Why did you use H3O plus?
Because when a strong acid ionizes, right, we get H plus and whatever that conjugate base is. But when talking about acids and bases, we want to use H3O plus instead of H plus. It just means the same thing. But you're going to see H3O plus a lot more. It's just basically taking that H plus and tacking it onto a water molecule. All right, so one more of these. Let's look at part C. We have 3.2 grams KOH in 450 milliliters of solution. So I need to convert my grams to moles, right?
Is this a base?
What?
Isn't KOH base?
It is. Is it a strong base? Yes. Good. Strong base. Right, because I have a group 1A element attached to OH. So my 3.2 grams of KOH times I can't do that in my head. 56.1 grams per mole. 0.057 moles. And then I want to divide by my liters to get molarity, right? Zero point 127 molar KOH. Okay, so KOH, strong base, so it completely ionizes. So that means I get a concentration of OH minus that also equals what? 0.127. So I need to get my POH first. Which is 0.897. Yeah. And then my pH equals, how do I go from POH to pH? 14 minus 0.897. 13.1. We'll just leave it there. She said it could be worse.
It's gonna get worse.
Yeah, we're getting there. Okay. Next up, let's take a look at, turn to the worksheet that says topic 8.3 on the top.
pH plus OH is always 4.
Alright, so let's start with number 2, because one of the struggles with my other class was just writing the right equations. Okay, so number 2, it's saying write the reaction for the following weak acids reacting with water. CH3, CH2, COOH. It's a long acid. Okay, plus H2O. But if it's an acid, it's gonna do what? Give NH. Good. So we're gonna just take this one off the end here. Right? Give it to H2O. And we're gonna get H3O plus the rest of that piece. I'm gonna have to and what happens to the charge when I take off an H plus? Negative. Good. Okay. So let's write our Ka expression. We don't have any numbers to plug in. Right? So I want products over reactants, right? So H3O plus CH3 CH2 COO minus. What's going to go on the bottom of my expression? What am I leaving out? Leaving leaving out the liquid. Good.
Will they take points off if you don't put like a little plus or a little minus after the product? Or just like get used to doing it?
I don't know if they would take a point off for that. Just try to get used to doing it, just in case. Okay.
Who grades these? Like, who grades everyone thing?
So every year, they invite AP teachers from across the country to come to one location, and everyone sits and grades.
Do they make sure that you don't get your own kids, or
I think they probably make sure that, yeah. That wouldn't be fair.
have you ever done that?
No, like, I don't know. I don't know how you get picked. I've never been picked.
Sounds like a
wouldn't
headache.
want to get picked for.
You get paid.
Oh, okay. There's
You get paid, you know, a few $1,000s, and they put you up in a hotel and pay for your meals, and
that sounds like a pretty good gig.
it does, yeah. I would do it. Plus, I think that I've been told that it's very helpful to sit there as an AP Chem teacher and see what people are picking out of these things. You know what I mean? Like, are they docking a point for you not putting the negative sign there? So apparently you learn a lot when you sit there and hear how people are grading and reading. I mean, if they invited me, I would go. Okay, let's do B. Okay, HF, it's a weak acid. Okay, what are my two products gonna look like? Right, so think about it, right? What is one of my products always going to be when I have a weak acid reacting with water? Yeah, you should always see H3O plus on there. And then whatever's left from your acid when you pull off an H. So F minus. All right, Ka expression. H3O plus. F minus. H. F. Okay, we good with that? So let's, without using a calculator, determine the Ka. Interesting. No, we don't need to do that. No. There's nothing with an iced tea ball. Okay, let's do, I'm gonna make one up, I guess. molar weak acid solution.
What? I think it's on the back page.
I'm making this up.
Oh, that's. But yeah. It's like,
Okay, making it up. Alright, so we have a weak acid in water and we want to calculate its pH. What's the first thing we have to do? We were doing these yesterday.
oh.
We need an ice table, and in order to do an ice table, we need to write out the equation. Good. So if we have HA
Yeah.
plus H2O, we are going to have H3O plus A minus. And yes.
Now when it's like calculating pH, could yours, is H2O always gonna be the equation?
So because it says solution, yes.
Okay.
Yep. All right. So we want to do an ice table. We have 0.2 molar x 0, 0. Okay. What's my change under my weak acid?
Plus X. No. S. Minus X.
Minus x. And then plus x is on this side. How would I know that?
You should say X.
How would I know that I'm plussing my x's on
Because
this?
there's can't go negative.
Because you can't go negative, yeah. So I have 0.2 minus x, x, x. Okay, so now I need to write out my expression for Ka. Okay, so what goes on top of my Ka expression using x's? X squared, good. What goes on the bottom?
Which is
0.2 minus x, which I'm going to be able to cancel that out, right? Because my Ka is so low. 1.8 times 10 to the negative fifth. So assumption-based solving, my x is so small, it doesn't have an impact on the 0.2. And I get x equals 0.0019. Did you not get that? Okay, so what important substance does my x equal that I can use to figure out pH? H3O plus, right? See my x here, that's my H3O plus. So now I can do my pH equals negative log of that number. And I get 2.7. Anyone else? 2.7?
Yes.
Okay.
Miss Campbell, for some reason my calculator, I did 1.8 times 10 to the negative 5 divided by 0.2.
You're not dividing by 0.2 though.
Oh, that's what it is. That's
Yep. All right, so let's.
Em has nice handwriting.
KB is
Yeah, I made her write my planner.
okay. So let's see if you can write out the net ionic equation of NH3 plus water. Okay, see if you can write that out. Okay, you can do it.
Yeah, that's right. T, not the negative piece. That was a nice
It's
graph.
out of here. Cherry bubbly.
Yeah.
Or the same one. How it's spelled out.
Like nuh-uh spelled out. I like
Nuh-uh.
Wait, how do you even spell that?
nuh-uh.
Like this? Nuh.
Yeah. You like that? I like that.
I like the word ooh spelled.
No.
Alright, so my NH3 plus H2O gives me
That one.
what two products?
H3O plus NH2 minus.
Okay, so you're thinking right if this was a weak acid, but if this is a weak base,
OH minus.
instead of, so it's going to take on an H, right? Remember bases are H plus acceptors. So we get NH4 plus OH minus. Okay. So now we're gonna set up an ice table, right? So 0.75 minus x plus x plus x. We have a nice small KB again, so we can simplify this expression that goes in the denominator. Okay. So I get x squared over 0.75 equals 1.82 times 10 to the negative fifth.
Wait, what were we solving for again?
The KB.
Are these ice tables, are they always going to have the reactants minus X because of the way that they're going?
For now.
Okay. Alright.
It's going, it's about to really complicate itself.
Oh,
So for now,
Can we assume if it's an acid base plus
then
water that it's gonna be normal?
yes, yes,
and that's gonna stay consistent?
yes,
Acid or base
yeah.
plus water, okay.
yeah. So I get x equals 0.0037. Okay? But it's time to examine what x means, right? So x in this case, what is the important concentration that we can tie it to? OH. So that means we have to solve for what first?
POH.
POH. Good. So POH equals the negative log of this.
I do. Yeah, this is actually not that
So pH equals 14 minus 2.4.
Are we doing 8.4
Are we doing 8.4 what?
Are we gonna do 8.4 before I leave?
We're gonna start breaking it down.
Okay.
Okay, so what we have done so far, right, is one substance in water. Either a strong substance in water, so one substance, right, and I mean acid or base in water. Taylor didn't like my questions. So, is it strong?
Don't worry.
Is it weak? Okay, so if it's strong, we do what?
100% assume that it's fine.
100% ionization. Acid concentration equals H3O plus concentration, or base concentration equals OH minus concentration, right? Because it completely ionizes. And then we use pH equals negative log H3O plus, or POH equals negative log OH minus. Okay?
What do you think was the worst unit in this lesson?
8.4.
Okay, that's what I assumed. I just was hoping that there wasn't getting this.
8.4 will take us a few days.
Few days.
Yeah. All right, is it weak? So if it's weak, we use Ka or Kb to find, oh wait, hold on. Don't forget in the ice table. To find H3O plus or OH minus. Okay.
Miss K's.
Well, Miss Case just needs to be emptied more often, and does it get
For like
emptied?
half of the year, it was like unaligned, and I just lived with it. Like I just lived with none of
There's
my like, none of the holes matching.
I fix it every once in a while
Okay.
when I'm in there, but none of it.
Okay, so now, right, that's one substance in water. So now we're going to move on to a far more complex flow chart with many, many, many branches of, right, two substances in water. Right, acid plus base.
And this is for
Yes. This actually, you guys are just gonna have to let go of knowing what section this is, because this is going to pull in information from multiple sections, okay? So we're gonna have to, I know we really like to know what specific section we're in and feel like we're skipping sections, but we're gonna have to let go and let God with the flow chart. Can we do that?
Yeah, I love like that.
Okay.
So should I just title it Flowchart?
No, title it two substances in water acid plus base.
Yes.
That's the title.
See, I knew Teresina would not handle not knowing the number.
Just blast the top.
two substances in water. I have found, and hopefully you can trust me with this, that this is the best way to put all of this information together. Okay, so the first question is it strong plus strong? Is it weak plus weak? Is it strong plus weak? Okay, so this will be section 1 of the flow chart, section 2, section 3. Guess which part is the hardest?
Section
2.
2, section 2. Yeah, because section 2 gets divided into 4 new sections.
How much room do you think we have on these papers?
Wow, exactly.
I love me a good food
Okay.
Maybe I need to restart
What?
So we're gonna start with section 1. So it's up to you. That flow chart, right? Leave it on a separate sheet of paper for right now. Okay? So move to a new sheet of paper where we can do section 1. Because we're gonna slowly like add our little hints and clues to our flow chart. Okay, so section 1, strong acid plus strong base. Okay. So for this section, what you want to do is you want to find which one is in excess. Hmm?
Does that mean like more ratio stuff?
Kinda, yeah. It's a little less complicated. Well, yeah, it's more. Hmm? Yes. Right, so all of this is finding the pH of a solution when you have an acid and a base in water. Okay, so you want to find which one is in excess, right? And then use the excess H3O plus or OH minus to solve for pH.
Is it kind of like an option? Like this like option?
No. Yeah, so this is a great, I hear what Taylor is saying over there, and the best way to think about it is to do an example. Examples of all of the flowchart stuff in my little notebook. One of these days I'm gonna organize everything. It's not strong. Okay. So here would be an example, okay? Find the pH of a solution that results when 250 milliliters of obviously we know that we're in the section of the flow chart that's strong plus strong. But let's just get in the habit of identifying our substances and labeling them as strong acid, strong base, or weak acid, weak base. Okay? HCl is one of my big six, right? So strong acid, strong base.
Are they mixed along with water?
Yes.
Or just the two?
Yep. Okay, so the first thing I want to do is figure out how many moles of each I have. Okay? So if I have 250 milliliters of 0.25 molar HCl, multiply them, but I
By
need
liters.
by my liters. Good. So I have 0.250 liters of HCl times 0.25 moles per liter. Right? We're comfortable converting between liters and moles if we have molarity. And then I have 0.150 liters of NaOH times 0.20 moles per liter. So this is HCl, this is NaOH. Alright, so these two substances, because I have one H and one OH, are going to react in a 1-to-1 ratio. Okay? So which one of these is going to be in excess? HCl. And then how much excess am I going to have? You just subtract. Okay, so excess HCl equals 0.0625 minus 0.030. 0.0325 moles HCl. Okay, so that means, right, all of my NaOH reacted. All got neutralized. So the only thing left floating around in solution now is some of that strong acid and water. So if I know my moles of HCl, can I get my molarity of HCl? Right, but I have to use my, this is for Teresina, I have to use my total volume of solution, right? I have to use my total new volume. So my molarity of HCl is 0.0325 moles. Okay, and what's my new volume of the solution? 0.4, yeah, so this plus this, right? So I get a molarity of 0.081 molar. So since that's strong acid, I can assume that that molarity of HCl is also equal to what concentration? Right. That also equals H3O plus. So So now I can just plug it into my pH equation. Okay? One point one-ish. Right? And then go back and say, okay, does this make sense? I mixed some strong acid with some strong base. All of my strong base got neutralized. I'm only left with strong acid in solution. Does a pH of 1.1 make sense for a strong acid? A nice low pH? Yes. Right, so your strong acid pHs will be in that 0 to 1 to 2 range. Your strong bases will be in that 12 to 13 to 14 range. Does that make sense? Okay. All right, so let's look at another example. Alright, so let's start by identifying our two substances. Okay, so we have KOH. What would we identify that as? Strong base, good. And HNO3, which is a strong acid. Good. The first thing we want to do is convert both of those to moles. Okay? So what does it look like we're going to have in excess this time? KOH, good. And we're going to get our excess KOH by doing what? Subtracting, good. Okay, next step. Am I going too fast? Right, I want to take my moles of KOH, right, to get my molarity. I want to get my 0.200 moles and divide by my total volume. Molar KOH. Okay, so that's a strong base. So if I have that molarity of KOH, then my concentration of OH minus is the same thing, right? I'll send you, I'm recording so I can send you what we do.
So first, let's go.
Well, we're not in the middle section yet.
I'm guessing we're doing that last.
We'll do 2A maybe today. I'll let them have a little break first. Alright, so if I have OH minus, I want to get POH first, right? So POH equals negative log 0.267. So 0.57. And then my pH from that is
13.4.
right. So I'm gonna take my POH and subtract from 14. Okay, and again, think about your answer. I was left with what in excess? Strong base. Does it make sense that I have a high pH? Yes. Okay, so really that's the theme of going through this whole flow chart is what is in excess, what's still floating around in solution that has an impact on pH. Okay, so you guys can take like a 5-10 minute break.